Okay, first off, tests were graded in the grade book. I don't really like posting the actual test stuff. I know that, yeah, I definitely haven't sent it to you yet because that's because I still have a couple people that have to do it. But the curve was pretty steep, and as I kind of mentioned yesterday, there's only really one person who took advantage of it, and they were rewarded handsomely. But everybody else got some type of. It's not to look up now. I mean, I go through the effort of putting it in that same day, so I would hope you guys can check it before you walk in here, but not in the middle of class when I'm trying to do something else. That would not be ideal. Then next week on Thursday, you have your performance final. That's going to be 5% of your final grade. Huh? Thursday. Next Thursday is your performance final. It's not a huge grade, but I mean, if to put things in perspective, it's basically equivalent to all of your weekly assignments combined. You know, it's kind of, which in itself is not a huge grade, but say that again? Didn't your grade percentage go up? A little bit, but that gets kind of squashed by the practice test because I mix them all together. And then on top of that, because I told you before, I'm looking for any possible way to inflate your grade. Like, I mean, please don't come to me if you guys have a failing grade and tell me why did I fail. But, you know, with the exception of only one person, and I'm not gonna say who that is. If you've been showing up to class regularly, like you are either passing or at least like in credit recovery range. The only people who I would see that are gonna have to repeat this again are the ones who just never show up. And even then, I have a couple kids that never show up and are still passing. So go figure. I don't know what else I can do. So, like those homework grades, the assignment grades you're referring to, if you do better, a lot of you lately haven't been doing it. A lot of you have never been doing it, but now I started replacing them with the test grade, so that's boosted some grades up a little bit. Anyways, the content, to try to kind of just make it more streamlined, and heck, if I can't get you guys to study for one test, I can't get you to go back and study an entire semester. So the performance final will be entirely based on the test that we just took. So I guess that could be a good thing or bad thing. The good thing is it's condensed. The bad thing is how some of you didn't do very well on it. Now, another good thing would be then I could treat the review for this test. I wanted to do it as early as tomorrow, but I don't know. I got to see how many people make it up today. But whenever I do that makeup for this past test, the one you took yesterday, that would act now as a review for the performance final as well. Make sense? Did you hear anything I said? I'm getting like a blank stare from Angel. No? Okay. Yeah, I gotta see if the only thing I'm missing is the kids that never show up and never take tests. The heck with it. I'm gonna go with it. I'll go over the test tomorrow. But there's like one or two kids who I want to see if they're gonna take it today or not. Worst case, by the beginning of next week, we're going over it, and again, that's gonna act as a review for the performance. So next Thursday is the performance final. Yeah, yes, sir. When is Thanksgiving? The fourth Thursday of November. I believe that's when it always takes place. Oh, I don't know. 27th, maybe, something like that. 25th, is that what it is? 25th is Christmas. Saturday's the 21st. So then 27th makes sense. All right. So this is the last unit. We're starting the last unit of the year. That's right. That's $1 million question. Is it easy? I don't know how to answer that question, and I always try to avoid that because to me the word easy is a relative term. What's easy for you might be difficult for Angel, and vice versa. What I will say is it's different. It has basically little to no roots in geometry. So if you're worried about memorizing angle relationships, you know, you don't have anything to worry about in that regard. The other good thing is that you were introduced to this in Algebra 1. If you remember anything from second semester of Algebra 1, you've already seen this. And you'll see it again also in Algebra 2. This is kind of, so like after Algebra 2, when you need to get that forced math in, you kind of have an option, whether you go pre-cal or whether to go stats and reasoning. And again, not to use words like easy or hard, but most kids tend to think that pre-cal is the hard one and stats and reasoning is the easier one. So this is kind of more in the path of the stats and reasoning. This is what you would need to know for stats and reasoning. So, all right. So first off, we start off with just some kind of terminology. Yeah. Yeah, you got a lot of catching up to do. Sure, if you're behind. Sure, yeah. No, the thing that veers people away from summer school is that unless you're like ESOL, you gotta pay for it. And it's like over $200 to take a per class, huh? But then that's a question for your counselor. There's kids that take Gwinnett Online Campus. There's kids that take Georgia Virtual School to catch up. There's kids that take 2 maths in 1 semester. And maybe you could look into that, but that's a question for your counselor, yeah. If they're different, as long as it isn't cumulative and like where you need one for the other one, it's possible. Yeah. All right. So terminology. We're getting into kind of probability and data. And to start this, we get into sets, like into groups. So like if you have a subset, if let's say hey, we were to break this up into boys and girls. Okay, like what is a set of boys in here? What is a set of girls in here? I mean, I don't think there would be an overlap in those sets because there's nobody who is both a boy and a girl. But like, let's say within boys, I could say, hey, boys that are wearing black shirts. So like, what would be the boys here in the room would be Caden, Angel, huh? Well, I couldn't even see your shirt. I was looking at Angel, but I guess it's a jacket. All right, but fine. Then let's say blue. Then is that you're lying? That does not look blue. Fine. So then let's say navy blue. What would be the subset of boys wearing navy blue? And Caden, that would be a subset. That's within a set. The more important one, let's say the 3, an intersection and a union. Okay. When you do have 2 sets that are not mutually exclusive, meaning that there can be an overlap, let's say these are boys, and then born in Atlanta. So the boys in here are the same 3 boys. Were all 3 of you born in Atlanta? Okay, perfect. So then who here was born in Atlanta? And this could apply to anybody because the universal set can just be people in the room. How many of you were born in Atlanta? Okay, so only one person. All right, Atlanta and its suburbs, like in the greater Atlanta area. Damn, there's a bad example then. How about born in the USA? Would that work? Was there anybody that was not born in the U.S.? You weren't? Okay, perfect. All right. So we have 2 sets. We have boys and people born in the U.S., right? So basically everybody here was born in the U.S. except for one. There's 3 people that are boys, but in the middle, that intersection would have to be true for both. How many boys here were born in the U.S.? Huh? It would be the 2, yeah. It would be the 2. So that middle part where the overlap, I mean, you guys have seen that before. What do you call that? What do you call that type of diagram? A Venn diagram. So that middle portion is what has to be true of both sets. If there's anybody that falls outside here, In the universal set, like for the example I just gave, if you fall out here, it would be that nothing applies to you, which in this case would mean that you're a girl who was, are there any girls here that were born outside of the U.S.? Okay, then nobody would fall outside, outside of that, those two sets. Okay, a union, okay, just means everything. If I were to put boys and born in the U.S., anybody that has either one that's true belongs in the union, meaning you only need to meet one criteria to be considered part of the union. So like to show you on a Venn diagram, the entire Venn diagram, except for anybody that falls outside, that's part of a union. An intersection is just in the middle. Some verbiage that you might see, and is important, is in italics. The word "and" is associated with intersection. If you see the "or," that's associated with union. Those are logic terminologies. And logic, it applies to intersections, or logic applies to unions. You can't read off of anything. Okay. A complement is anything that's not. Who are the complement of the boys in this room? The complement means not true, that are not. If something is not part of a set. So who would be the complement? That was a joke. No, boys. If we're just saying now just boys, what are the complement of the who's not a boy? Correct. So it would be Miranda and Lana B. Okay. Complement just means not part of a set. Makes sense? All right. We'll do some examples. This is just introducing vocabulary. All right. So these are four sets of numbers, right? Set A is 1, 3, and 4. Set B, oh, by the way, this little line here means such as. So don't get confused. Just read what it's telling you. So this is saying B can be any number x, such as that x is an even whole number less than 9. What are the even whole numbers less than 9? 2, 4, 6, 8. Who do we appreciate? So I mean, it's just, if you need to just translate the words into numbers, you can do that. So set A is 1, 3, 4. Set B is 2, 4, 6, 8. Set C, they give you the numbers as 2, 5, 7, 10. And then set D is any x such that x is an odd whole number less than 10. What are the odd whole numbers less than 10? 1, 3. Why are you guys like going on all random orders? Just 1, 3, 5, 7, 9. You're going. Have you like clawed anybody with those things? I know, it looks like it. She can like skin somebody with that. All right, so what is the set then? A union B. Okay. By the way, the upward unions union. Did I say that up here? Oh yeah, good. See this symbol? That means union. If you turn the U upside down, that means intersection. If you see any of these, means complement, but actually this one here that I had to write in by hand, that's probably the most common way. If you see an apostrophe like that, that means complement. So A union B. Union means that it only has to meet one criteria. So give me any number that is either in A or, remember the logic word, or in B. Okay, give me any number that falls in here. Well, no, all. I'm sorry. Maybe give me all the numbers that fall there, because one or the other doesn't matter. When you use OR logic, okay, what you're gonna output, what you're gonna put out is any number that you see there. Correct, but if the number shows up twice, you only list it once. So it'll be 1, 2, 3, 4, 6, 8. That is A union B. You put any number that's there. How about C union D? 1, 2, 3, 5, 7, 9, 10. Good. All of those numbers are in either C or in D, one or the other. Either one is fine. Okay. Now, upside down U means intersection. What is the intersection of B and C? So now, in order to be in an intersection, you have to be part of both. What are the numbers that repeat in B and in C? Is it only 2? Yeah. And by the way, these elephant ear looking things, those are called braces. That's the notation that's used for a set. When you're going to write a set of numbers, people hate drawing them, myself included. Okay, how about A intersection C? What is the intersection of A and C? What numbers appear in both A and C? None. When a set has no numbers in it, you call that the empty set. The symbol for empty set you've seen before is what you've seen for like no solution. That's called the empty set. You're an O. O. Oh no. Alright, so here's a thick line here, so it means new problem. Here is a universal set. A universal set means kind of like, hey, they're already giving union. This is global. Another way of saying it is global. This is everybody in the classroom. 1, 2, 3, 4, 5, 6, 7, 8. Okay? This is a subset of that universal set. Within this universal set, we have set P. Therefore, what would be then the complement of P? Meaning, what are all the numbers that are in the universal set that are not in P? 1, 5, 7. This is the problem here. Problem. This is what you're being given. This is what you're being. Is what would the complement of P be? What are all the numbers there? People at home, can you see the screen? I know sometimes the screen gets cut off. Can you see that or not? Oh, somebody's connection is bad. No, I think both of them sounded pretty bad today. So let's get into probability. Probabilities are the chances of an event occurring. Yes. Okay. When we talk about probability, we want to know something occurring, right? Well, there's two types of probability: empirical probability and theoretical probability. But the example I always use are free throws when I teach this. Okay? You know what a free throw is? When they go to the free throw line and shoot? Oh, jeez. Okay. Okay, how about this? How about a coin flip? Have you ever seen a coin be flipped before? Yes. All right, so let's use coin flips, right? When I flip a coin, what is the theoretical probability that I'm going to get? Yeah, what's the chance of me getting heads? Okay, so because 1 is the number of outcomes I'm looking for, which are heads, and then 2 is the number of possible outcomes, and learn this word here in the sample space, which are heads and tails. Heads is 1 out of the both that are heads and tails, right? But now let's say that I flip that coin 10 times, and out of those 10 times, it came out heads. Okay, probability that says, okay, now if after I have gathered, if I were to flip that coin an 11th time, what is the likelihood that I would get heads? And I just saw it. I've witnessed it, and it just happened 7 out of 10 times. So I would have a 70% chance. Okay? Now, the thing I struggle with the flipping of the coin is that that's completely random. So, I mean, you can make the argument, hey, so I have a 1 out of 2 chance. There isn't much skill involved in flipping a coin, which is why I like to do the free throw thing, because when I shoot free throw, if I have a 70% free throw shooter, there's still only 1 or 2 possible outcomes. Either the ball goes in the basket or the ball does not go in the basket. So it's still 50-50 theoretically, but if free throws, he's made 70 of them, then there's a 70% chance the next one is going to go in. Does that make sense? So empirical probability is based on data. You've already collected data, so the chances, as Miranda says, would be skewed based on the data. Meaning it could go, hey, if damn, this is not gonna be a good example. Let's say we take percentages out of it and we just talk about pass fail. Okay? When you take a test, there's 2 possible outcomes. Either you pass it or you fail it. Okay? But in your last 10 tests, you've passed 9 of them. What is the theoretical probability that you're going to pass the next test? Huh? No. Theoretically, it's still 50-50, 50%. But empirically, what are the chances you're going to pass the next test? Yeah, 90, because we have data. We've seen you in the past pass 9 out of the last 10 tests. Does that make sense? All right. Let's continue. I would like to get all the explanation out today, and then tomorrow we can just keep on going. Okay? The probability of event not occurring. Okay? So if she has a 90% chance of passing a test, what percent does she have of not passing the test? 10. Now, what this also shows you is that a lot of times probability is expressed not as a percent, as a decimal. How do I turn 10% into a decimal? You move the decimal, right? Good. Okay, conversely, like if we were talking about her passing the test, 90%, you can also express 90% as saying 0.9. I'd even go as far as to say that a lot of times probability it's more likely to be expressed as a decimal. So if you ever want to know the complement, okay, that an event, something not occurring, it's called a complement, it would be 1 minus the likelihood of it occurring. You just told me she had a 0.9% of passing a test. So what's 1 minus 0.9? What? 1 minus 0.9 is 0.1. So that means she would have a 0.1 chance of failing. Okay? The kid with the free throws. If he makes 70% of his free throws, how do you say 70% as a decimal? 0.7. So if you want to know what's the chance of him not making the free throw, 1 minus 0.7. Okay. Hey, when Yannick comes up to bat, okay, what is the theoretical probability of him getting on base? Yannick plays baseball. Hey, that's a good question. Who is Yannick? No, Yannick is one of your classmates, but he plays baseball. You don't know about getting on base? Yannick, you want to help out?
I'm pretty sure there's like 5 people in, like 5 bases.
No, there's 4 bases.
Oh.
I think Yannick has left us again. It's 50-50. In baseball, when you come up to bat, either you get on base or you don't get on base. Okay? But now let's say that Yannick, and in baseball they actually use decimals. They don't use percentages. So let's say Yannick has a 0.763 on base percentage. Okay? Like in the past, that's this. He's got on base 76.3% of the time. That's his on base percentage. So if I want to find the probability of him not getting on base, 1 minus that. You just do 1 minus. 0.26, 0.237. Yeah, 0.237. You know, you like baseball better. That's why you wear the Dodgers hat. All right, and now this is where it gets a little bit tricky. And this is just, see this? I am not going to go over all of this in one day, because this is basically what we're going to go over until the end of the semester. This is not just 2 days worth of lessons here. Use this as a reference sheet. Okay? What we start going over here is compound probability. Everything I've discussed so far today is simple probability. If I am looking at the probability of one event occurring, simple probability means one event. Compound probability now looks at two events. And then we're going to get into, all right, are we looking at one event or another event, or are we looking at one event and another event? Are we going to say, what is the, what's the probability this weekend of Miranda waking up before 8 a.m. and eating eggs for breakfast? Okay, then there you go. Very good. Very good. Okay. Yeah, okay. So, hey, let's, guys. Hey, can we listen, please? So here's what I need you to do. Just know that these three right here deal with and probability. When you're looking at that, both events have to occur. These two deal with or probability, which is just one or the other. And I could argue that this is like most reference sheets only put this one here. And we'll talk about it. There's no need to really talk about it now because that's going to be spread out over the next few weeks. And then this last one I already talked about. Complementary events is like the same thing not happening. What's the complement? So. Mm-hmm. And yeah, which here, let's see who's learned something today. What is a word that is synonymous with and? What other word did we learn today? Very good. Excellent. That's awesome. Good. And, all right, has to deal where we're looking at the intersection of two events, the likelihood that they both occur. What word is associated with or? The union. When one or the other. Yeah, either you wake up before 8 a.m. or you eat eggs, which we know we're not going to eat eggs, but maybe we wake up before 8 a.m. No? Okay. What's lower, her eating eggs or you studying for a test? What do you think? He's thinking about it. Her eating eggs, probably. All right, here we go. Guys, look, I really want to get to this because then at the very least tomorrow will just be examples and then we're done with this. I want to get all the explanation out of the way. Fundamental counting principle, okay? Remember I used that word sample? This is used many times where we're looking to find a sample space, which are what are all the possible outcomes. When you go looking for how many things could possibly occur, this is used many times. Now, if you ever do get to, I want to say, because last year was the first time I did an Algebra 2. I think it might be part of Algebra 2, but if not, you would definitely do it in statistics and reasoning. There's something called combinations and permutations, okay, which it gets into that, but I don't believe that's part of. I did all this months ago, but I'm pretty sure that we don't get into that here. But this is kind of it's a way to figure out how many possible outcomes. Fundamental counting principle, here you go, perfect, and it's even underlined already. There you go. Think of that. Think of multiplying. So here we go, straight into an example. Suppose you walk into a pizza place and you look at the menu. In order to buy a one-topping pizza, you can choose from one of these crusts. How many crusts do we have here? There's 3 possible crusts. One of these sauces. How many sauces do we have? One of these toppings. Oh, 1, 2, 3, 4. I'm counting 6. Lana counts 6 also. So they would figure out then how many possible different types of pizzas can I make? Just multiply. That's called the fundamental counting principle. 2 times 36. There are 36 possible one-topping pizzas. And there's ways that people teach it with mapping and stuff. And I would show, hey, I can make a thin crust red sauce pizza with pepperoni. I can make a thin crust white sauce pizza with pepperoni. And where you go through all the combinations and you branch them out like into a tree. White sauce is Alfredo. Alfredo sauce. Oh man, no man. My favorite pizza now is Philly cheesesteak pizza, and that uses white sauce. It's just cheese. Alfredo sauce is just it's melted cheese is all it is. Where do you get the most widely available one is at Domino's. The Philly cheesesteak one is there. It's pretty good. But then you'll have these like little boutique-y, like smaller pizza chains that also offer Philly cheesesteak. Some of those like do they have Anthony's Coal Fire here in Atlanta? No. They have these like chains that do the pizza like in coal hot like brick ovens and stuff like that. Some of those will have yeah, it might have this sure is different names. Alright, here we go. A telephone number is made up of a 3-digit area code followed by 7 digits. How many phone numbers can be created with the 770 area code? So we are saying, hey, we're going to stick to 770, but then after that, we have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7 digits. How many digits are there? How many digits are there? Huh? Yeah, there's 10 digits. Now, this is not the most realistic question because when it comes to a certain number, like there are certain numbers that are restricted, like the first digit might only be allowed to be like numbers between 2 and 8 or something. And then, but let's just assume that any of those digits could be any, like any of those 7 numbers could be any digit. Well, there's 10 digits from 0 through 9. So this would be 10, 10, 10, 10, 10, 10, 10, or you could also just say 10 to the 7th power. And yeah, you would multiply them. You would. No, man, it's just going to be a 1 with 7 zeros, dude. 2, 3, 4, 5, 6, 7. How many is that? So there are 10 million possible numbers. Did you hear that now Atlanta's getting another area code? I forgot what number it was, but yeah. So it's 404 is the first one, 770, 470, 678, and now it's getting like a 5th one. That's the best one there. That's mine. You know what 305 is? It's better than Florida. Born and raised, man. 36 years in Florida. Because I'm crazy. Yeah, man. You get kids, you want to just slow things down a little bit. Better schools. A vanity license plate in a certain state can be created with 3 letters followed by 3 numbers. How many license plates can be created? 1, 2, 3. 1, 2, 3. How many letters are in the English alphabet? Oh dear, Miranda. Only one off, right? Fine. Hey, you know that there's like, I don't want to say a majority, but there's like a much bigger percentage than you would think of people that don't know how many states there are in the United States also. So there you go. You got that one right. Good. There you go. Who's that? Who's your favorite actor? I don't know who that is. Nope. All right, so guys, come on, let's get through this. So it's 26 letters, 26 letters, 26 letters, but then there's for numbers, the same thing, saying digits. 10 digits, 10 digits. So you're basically just doing 26 to the third power, but then putting 3 zeros after it. What's 26 to the third power? Ready, set, calculate. 17,576,000. That's the answer. Yeah, because when you multiply by 10, you put a 0 at the end. Yes, ma'am. Because there's 10 digits. So like it's how many options? Like the same way with a pizza, pepperoni, ham, options. If I'm gonna put a digit there, how many options do I have? I have 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 digits. In the, well, it's not even English. It's in number, in a base, like we live off base 10 digit numbers because there are 10 digits. Like in every place there is only 10 single digits. No caps. Three people are late to class. Hey, tell me about it. And I'll try to run through the same door. In how many ways can the three enter the doorway if only one person can fit through at a time? How many people? See, but now you gotta listen. If you can only go one at a time, okay? How many options are there for coming in first? 3, because there was 3 people. No, there were 3. We're looking at a sample space. So for the candidates for first to come through the door, there were 3. But now that person has walked through, how many candidates are left to be the second through the door? There's only 2 people left. Which means how many people would then have to oh, by the way, for some weird reason, when it comes to probability, a lot of times for multiplication they use the x. That's why I'm using it. Because it's not really in the algebra realm. And then how many people will be left to come in last? There can be only 1. So how many possibilities? 6. To try to give it some substance, if I were to say, hey, those 3 people are Muhammad, Miranda, and my boy Sammy over here. What would be those 6? Okay, Muhammad, Miranda, Sam. Muhammad, Sam, Miranda. Miranda, Muhammad, Sam. Miranda, Sam, Muhammad. Sam, Miranda, Muhammad, Sam, Muhammad, Miranda. There you go. Those are the 6. Bam! Pick up that knowledge I just dropped on you. All right, and then perfect. That leaves us in this. Oh yes, good. I like you. So tomorrow will just be practice. Let's finish this page. This will be the last page here, okay? Two-way tables. This was definitely part of Algebra 1 because I've taught it in Algebra 1 before. Okay, I just want to go over some of this terminology, and this is one of my favorite examples because everything here revolves around this guy. What did we call this again? Wait, no, it's a Venn diagram. Yeah. Okay. And this is talking about, I guess, people in one group of like students, right? And we're comparing whether they're taking a foreign language and do they play a sport. How many people are in this sample? What is the universal set here of people? Say it again. Should be 50. What is 23 plus 14 plus 10 plus 3? Should be 50. Okay? Out of that 50, there are 23 that take a foreign language but do not play a sport. No way. Do you have the 3? Yeah. The three do nothing. The three are the complement of that union. Okay. So 23 people take a foreign language but do not play a sport. 10 people play a sport but do not do a foreign language. They're part of the union because in a union you only have to do one. But then the intersection, the people that do both are 14. There are 14 people playing a sport who also take a foreign language. There are 3 people that do neither. And that same information is now expressed in what's called a two-way table. Okay? So let's go over some of the terminology. The marginal frequencies. What is the word? What is the root of the word margin? Huh? Margins. Margins. Okay. So what marginal frequencies are when you are the tallies for the columns. And this is, I mean, it's being a little bit too expressive. Let's do just a number. Those are your marginal frequencies, where you're adding up the columns and the rows. Okay? Your joint frequencies are what are in the body. These numbers that we see here are the same numbers that we see here in the body. Those are called the joint frequencies. Okay? Relative frequency is the observations in a category divided by total observations. So these are already ratios. These are kind of like probabilities. So if I were to say, hold on, yeah. If I were to say, what percentage of kids, here, perfect. This 14, which was the intersection, what percentage of the total group does that account for? Well, there were 14 out of 50 total. 14 divided by 50 is 0.28. 28% of those kids are doing both. Okay? That is called a relative frequency. Now, if we do conditional relative frequency, what we're doing is we're applying a condition. We say, hey, out of the kids that play a sport, we're limiting the sample. How many kids play a sport? How many kids play a sport? 24. Yeah, because all of these kids play sports. They're in the sport bubble. And you can see that here in the margins. So out of those 24 kids, how many also what percentage take a foreign language? So you'd still be dividing, but instead of dividing the 14 by the 50, you would divide the 14 by the 24, because you're limiting the sample. Yeah. So I just wanted to expose you to the terminology. And then what we will do tomorrow is just spend the whole time doing examples, and that we should have plenty of time to be able to get through that. If I can get people to finish the test, maybe we can start going over the test, and that'll be your review for the for the performance final. So, any questions?
Is it gonna be like the ones where we have to like follow?
Yeah, I'm gonna give you a group, and I'm gonna give you 4, and you pick 2. And they're not meant to be overly difficult, but you have to understand coordinate geometry. All right, let's see who made it.